So this video will show how to define variables and also the solution to the swap command that was done on slide 6. So when we make a variable, we go into the variables palette area and we just type the name of the variable, and then you can see now that that variable I typed, Alice seat, is there. And we're going to define another variable called Bob seats. This just represents storage locations indicating where Alice and Bob might be seating, say, on a plane. So instead of assignment in Alice, we have a set command. So set's the same thing as assignment. What's on the left-hand side of the variable is set to be equal to what's on the right-hand side or after the 2. So I'm setting Alice to be in seat A15 and Bob to be in seat B6. So we want to look at how we do the swap command. And the naive solution that we presented in the slides was to just simply set Alice equal to Bob and Bob equal to Alice. So that's not going to work. And if you look at the canvas area, you can see that there's a set command, then there's a change command, there's a show variables, there's a hide variables. So the showing of the variables will give us the values of Alice and Bob as we run our program. So if we ran our program, we see that both values are set to B6 because I'm just copying Bob into Alice, which copies B6 into Alice, and now just copy B6 back into Bob as we showed in the slides. So we want to look at the two ways that we solved this. One way was to introduce a temporary variable and use that as a holding place for the intermediate value of the first variable we want to store. So here we're setting Alice to temp, and then I'm copying Bob into Alice. So Alice is being overwritten, but we stored that value of Alice previously in temp, so I can now take that stored value of temp and put it into Bob. So in this case then we do get the desired result where the values of Bob and Alice swapped. So you can see that in the values of the variables at the top, and we're just moving A15 into temp, then B6 into Alice, and then A15 back into Bob. So that works if we have any kinds of variables. If we know that our variables are actually numbers, we can use that second trick where we're using just addition and subtraction. This is actually pretty clever if you watch and see how this works. So in this case, I'm setting Alice to be equal to the sum of Alice and Bob. So I go over and get the addition, and I'm just taking the sum of Alice and Bob and overriding that as a new value. So in that case, Alice plus Bob would be 21. And then I'm setting Bob to be equal to Alice minus Bob. So it's the x minus y that we saw on the previous slide. So in this case I have Alice minus Bob. And then the last statement, the last set statement, or the last assignment statement that I need is to then set Alice equal to Alice minus Bob. So it's the exact same arithmetic expression above, so I can duplicate that and just copy it into here. So if I run this program, I get a very similar result of the swap. So in this case, Alice was 15, but now 6, and then Bob was 6, now 15. So we take the sum there is 21, and then 21 minus 6 makes Bob 15, and then if we do that again, 21 minus 15 makes Alice 6. So that's the way, if we have arithmetic expressions, we can use some shortcuts and also do a swap operator. So we want to be able to swap two variables, and the challenge again, as we pointed out in the slides, is that the semantics of assignment or the semantics of set is that once I set a value on the right hand side equal to the variable, I overwrite the previous value of the variable. So we had to have some way to store that. For the first example we saw, this first solution, I had a temporary variable. So this is a very interesting discussion that your students need to know. If they understand this, they should understand the semantics of assignment or set as an overriding semantics. So we want to make sure that we know how to declare and create variables. So the make a variable block in here, and then I can set the variable or assign it. I can change it by a certain number, and I can show or hide the variables as they appear in the canvas area of the stage, as we saw in this example.